Hey mathematicians, today we are going to talk about finding the sample space for compound probability. Compound probability is just what happens when you have multiple probability events, okay? So maybe we're flipping a card or flipping a coin and pulling a card or whatever, okay? So number one, draw a tree diagram showing the sample space of flipping a coin twice. So coin flip 1, I know I can either get heads or tails. So my tree is going to have the option for heads and the option for tails. This is coin flip 1. I need to flip it twice. So after I get heads, I'm going to flip it again. And I could either get heads or tails. But if I got tails the first time, I could also still get heads or tails. So this is flip 2. So the way this tree diagram works is I would just start here and work my way down, and this would say I got heads, heads. Or I could go down this way, and that would say I got heads, tails. I could go this way and get tails, then heads, or tails, then tails. So when I flip a coin twice, here are all of my possibilities for the outcomes. Okay. Number 2, draw a tree diagram showing the sample space of flipping a coin, then spinning a fair spinner with 4 sections. So we're going to start with our coin flip. We know the options are heads or tails. And it doesn't tell us what our 4 sections for our spinner are, so I'm just going to number them since there are 4. Once I flip my coin, if I get heads, I can then spin my spinner and get 1, 2, 3, or 4. If I flip my coin and get tails, I could also spin my spinner and get 1, 2, 3, or 4. So my options are heads 1, heads 2, heads 3, heads 4, or going down this way, tails 1, tails 2, tails 3, tails 4. So you can see I have 8 total possible events in my sample space. All right, number 3, draw a tree diagram showing the sample space of drawing a card from a deck of 5 cards, then flipping a coin. Now, just because we've done our tree diagrams going vertically doesn't mean you have to. You could also go horizontally. So I'm going to draw from a deck of 5 cards. It doesn't say what they are, so I'm just going to number them. 1, 2, 3, 4, and 5. And then I'm going to flip a coin. And I know when I flip a coin, it's either going to be heads or tails. Once I have drawn my card, I can flip my coin, and I know that my options are going to be heads or tails. Heads or tails. I did not give myself a lot of room. So no matter what I got on my coin, I can still get heads or tails on my, no matter what I got on my card, I can still get heads or tails on my coin. So that would be a 1 and a heads, a 1 and a tails, 2 and a heads, 2 and a tails, 3 heads, 3 tails, 4 heads, 4 tails, 5 heads, 5 tails. So you can see those are all the options in my sample space. Those are all the different possibilities I could get for that situation. Okay, number 4. Draw a tree diagram to show the sample space of pulling a marble from a bag of 2 red, 4 blue, and 1 green marble, then flipping a coin. So I'm going to go red, red, blue, 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 and 1 green. So there's all of my marble options. Now I'm going to flip a coin. Heads, tails, heads, tails, heads, tails, heads, tails, heads, tails, heads, tails, heads, tails. So you can see those are all my possible outcomes. All right, number 5 is a little different. Make a table showing the sample space of flipping a coin 2 times. So I know I could get my first flip, I could lead with heads, or I could lead with tails. So if I'm going to lead with heads the first time, I could get tails the second time. Or I could get heads the first time and get heads the second time. If I got tails the first time, I could get tails the second time, or I could get tails, then heads. Now, if I had more options, I would obviously put more rows or more columns on my table, okay? Number 6, make a table showing the sample space of drawing from a deck of 4 cards, then rolling a fair die. So here we've got more spaces, right? For the die, I've got 1, 2, 3, 4, 5, 6, and then for my sample space of 4 cards, I've got, we'll call them A, B, C, and D. So I could get card A, roll a 1, card A, roll a 2, card A, roll a 3, card A, roll a 4, card A, roll a 5, card A, roll a 6. I could get B, roll a 1, B, roll a 2, B, roll a 3, B, roll a 4, B, roll a 5, B, roll a 6, C, roll a 1, C, roll a 2, C, roll a 3, C, roll a 4, C, roll a 5, or C, roll a 6. D, roll 1, D, roll 2, D, roll 3, D, roll 4, D, roll 5, or D, roll 6. So you can see I've got 6 options across, 4 options down. My sample space has 24 different possibilities. All right, number 7, make a table showing the sample space of rolling a fair die, then flipping a coin. So we know rolling a die has 6 different outcomes. And then flipping a coin could be heads or tails. So we could do 1 then heads, 2 then heads, 3 then heads, 4 then heads, 5 then heads, 6 then heads. We could do 1 then tails, 2 then tails, 3 then tails, 4 then tails, 5 then tails, or 6 then tails. All right, last we have make a table to show the sample space of spinning a fair 3-sectioned spinner, then drawing from a deck of 4 cards. So let's make a table to represent that. Let's say the spinner has red, blue, and green sections. And my deck of cards, 1, 2, 3, and 4, okay? So I could get red and 1, blue and 1, green and 1. I could get red and 2, blue and 2, green and 2. I could get red and 3, blue and 3, or green and 3. I could get red and 4, blue and 4, or green and 4. All right, number 9 says, using the counting principle, determine how many possible outcomes there are if you draw 1 card from a standard deck, then flip a coin. So the counting principle basically just says to use math to solve out how many possibilities there are. If we look back at the previous example, our table had 3 options across the top and 4 options going down the side for a total of 12 options in our sample space. So we can take the number of events in our sample space for one event, the number of events in our sample space for another event, and multiply them to get our total sample space for our compound event. So if we're drawing 1 card from a standard deck, that is 52 cards. Then we flip a coin. There's 2 sides to a coin. So we have 104 different outcomes. Could we list them all? Yes, but why would we want to? Okay, using the counting principle, determine how many possible outcomes there are if you pull from a bag of 1 red and 2 green marbles, then spin a 3-sided spinner. So with my marbles, there are 3 marbles that I can pull from, and then my spinner has 3 sides, so I have 9 total outcomes. Using the counting principle, determine how many possible outcomes there are if you draw a card at random, put it back, and draw again. So when I draw a card the first time, that's 52 cards. I'm going to put it back in the deck, so I still have 52 in the deck. So I'm going to multiply those. I have 1,144 possible events. Again, could I list them all? Yes, but we do not have time to list that many possible events in my sample space. 12, using the counting principle, determine how many possible outcomes there are if you spin a 4-color spinner and choose a card from a standard deck. So that is 4 on my spinner, 52 cards in a deck, so I'm going to multiply those. And that gets me 208 possible outcomes. So that is our 3 main methods that we can use. You can also use an organized list, but honestly, making a table seems to be a little bit quicker. So that's all the ways that we have of finding our sample spaces for compound probability.